every business wants to experience. 80% of the company's revenue depends upon the real-time analysis. However, the structure of the data, let it be structured data or unstructured or semi-structured data, can hinder this process. So this session, let's discuss the differences between structured, semi-structured and unstructured data. Now data can be classified into these three types: structured, semi-structured and unstructured, based upon the formats, based upon its scalability and analysis implications. So let's try to first understand what is structured data. So as this picture itself shows that structured data looks more organized. Semi-structured is kind of between a structured data and a unstructured data in terms of organization, and unstructured data is completely an unorganized way of storing the data. So let's first discuss about what is structured data. As the word itself says, the main goal of this is organizing the information in a structured way. So the main goal here is to ensure consistent structure in the data. Now both machines and humans can interpret this data, and therefore it ensures efficient organization, categorization and storage. You can think of structured data of just as an organized spreadsheet, where each column will have a purpose and each row will have a purpose. So the columns you can be used to describe the attributes, features, fields, and the rows can be used to describe the entities, cases or records. Now the data in a structured data can be easily retrieved using various tools, and very commonly used tool is SQL. Now the structured data is encountered in machine learning in three ways. One is record data, the second one is data matrix, and the third one is graph data. Now coming to record data, now record data is a data set where you have some collection of measurements which you have taken from some kind of a process. Now the measurements that you have taken from a process, let's say I am trying to take measurements of the different kinds of flowers which we have discussed before, like iris, setosa, petunia, some three types of flowers. We are trying to taking the measurement of the sepal length, sepal width, petal length and petal width. So these are the measurements you have taken for the flowers, for some 50 samples, let's say. So I'm going to organize these measurements in the form of a matrix. Okay, so let's say I give the columns, right? The columns are basically going to have the attributes or the features of the flowers, and the rows are used to store the entities or the cases or the records. Normally what happens is each row we call it as a record, and we will have some kind of labels, right? Suppose in this case I have first name, last name, address, city, age, right? Suppose I have another column called as the name of a person. Now the name of the person would be the label. In the example of flowers, the name of the flower, iris, setosa or petunia, that's the name of the flower. So that can be used as a label which is used to describe the individual observation. Now the second type of data, structured data, which we normally encounter in machine learning is data matrix. Now this is also very similar to record data in the sense I'm going to have a table like this where I will have columns and rows. But this main difference here is data matrix mainly consists of numeric attributes. What here you are seeing in this example is a record data, because I am having numeric values as well as I am having other characteristics as well, like name, city, address. But data matrix will exclusively have numeric attributes, right? And since it has exclusively only numerical values, I can also do some matrix operation on this data. So you can also say that in a data matrix, the data can be thought of as vectors or points in a multidimensional space. So suppose I'm doing some work of measurements, right? And let's say measurements of some kind of deviation in a structure in an image. So the measurements probably I could have done based upon the geometrical values. The radius value I could have taken the length, I could have measured the circumference, I could have measured the width. So these are all numerical values. So therefore I can do any kind of matrix operation or mathematical formulas can apply to that. So such kind of data matrix where you just have numerical values, they are called as data matrix. The third one is graph data. The graphical data, as the word itself says, here we are modeling the data in the kind of a graph. So it's basically giving us relationships among the objects. Okay, so one simple example is I can have a web page which is referring to another web page. So if I try to refer this or make this in the form of a graph, I can say I can represent the web page as a node and the connection between the web page, right, or between the nodes, I'm going to call it as a edge, or the hyperlink, right, is called as an edge. So that is about graphical data. So in machine learning, you will, depending upon your work, you will be encountering such kind of data sets: record data, data matrix, or graph data. Now there is another fourth type of structured data, which we call it as ordered data. Now ordered data will have attributes which will have some kind of an order in them. As the word itself says, it has some kind of an order. You need some kind of an ordered information in that. Now even under ordered data, I have different types like temporal data, sequence data, spatial data. Okay, so ordered data can be further classified into temporal, sequence, and spatial. What is ordered data? As the word itself says, here the data will have some kind of an order. Right? The first one, temporal data. As the word itself says, temporal means what? Time. So here the data is associated with time. So I can have lot of measurements where the values will vary based upon the time. So let's say I'm talking about purchase pattern or the sales pattern. The sales may increase during festival time and may come down during the other times. So this kind of a representation where I'm giving on the x-axis, let's say the time, and on the y-axis I'm putting the purchase information. So that becomes a temporal data here because the data is associated with time. Or we also call it as time series data, which is a special type of data where the data is measured over the time. And some other examples are, as you can see in this diagram, weather patterns, right? The weather will vary depending upon the month or the time. Traffic conditions. The traffic can be more in the morning and less in the afternoon. Studying demographic trends. So these are all examples of temporal data as shown in the first diagram where we are having time and the data in the y-axis. The second one is and also this is an ordered information because you have some kind of implicit order in this kind of a pattern. You will see some kind of a pattern here in the data which will show some kind of an ordered kind of data. The second type of ordered data is sequence data. So here you will have sequential data, again some kind of a order, but there is no timestamp. So there is no relationship with respect to time here, but there is a sequence. And very good example of this is the DNA sequencing where you have 4 characters ATGC, right? So DNA sequencing where you have some kind of a sequence, right? So that is an example of sequence data. The third one is spatial data. Spatial means position or area, right? So such kind of data where you have measurements of data with respect to position or area with respect to, so you are having some kind of data where which is associated with locations, maybe coordinates, maybe projections, or some kind of discrete or continuous values, relationships. So very good examples of this like cartographic symbologies as you see in this diagram, right? So this is an example of spatial data. Okay, so where you have the data associated with attributes like location, position, area. So that's an example of spatial data. Now these three comes under again ordered data. So to quickly revise, structured data are of 4 types: record data, data matrix, graph data, and ordered data. Under ordered you have temporal, sequence, and spatial data. Now coming to the next one, unstructured data. As the word itself says, here the data does not follow any kind of predefined format or structure. So it is completely different from structured data. There is no format here, like there is no kind of organization of information here. You can just think of unstructured data like a pile of documents, or you have some pile of recordings which is very good in content. There is good lot of information, but there is no categorization. There's no organization. In fact, 80 to 90% of the data that we come across when we are working on machine learning is all unstructured data. You have a lot of content, it's rich in content, but there is no organization, there's no categorization. So this data is actually very good. It's a gold mine of information. However, due to the variable format, and it can be a challenging process to understand this data and use this data. And even computers will need lot of extra instruction to get content from this data. But it is good in data, but you need lot of extra work to be done to get the content. And some very good examples of this is social media post, sensor data, emails. If you try to get these kinds of data from the from some kind of open repository, you will see that it's good in content, but there's not much of a categorization. So you will have to put in that extra effort to make it more organized, right? So, but this has immense potential. Because it's very good in content. There's a lot of information in the data, but it's not categorized. That's the only problem. Okay, so that's the main challenge, and also it can be difficult to share across geographies. So some examples of unstructured data are text files, documents, video files, emails, audio files, sensor data, server, websites, images, social media information. These are all IoT sensor data. All of these are examples of unstructured data. Now coming to the third category, that is a semi-structured data. Now this is going to bridge the gap between the free-flowing unstructured data and the organized structured data. This may possess some kind of internal organization, but still it does not have any kind of strict predefined format like you have in structured data or like in a spreadsheet. Okay, so it's kind of between a structured data and an unstructured data. It does have some kind of internal organization, but still doesn't have any kind of rigid formats or rigid structures like in structured data. Okay, so some of the main, so it's basically trying to give a balance between structured and unstructured data. And very good examples of semi-structured data are JSON files, XML files, log files, right? So these kinds of files, if you have already worked on it, RSS, JSON, XML, HTML, if you want more information about this, when you're working on machine learning exclusively, you will be working many times with respect to you. We take a lot of data from JSON, XML, HTML. We need to work a lot on this kind of data, and how to work on this kind of data I will give you the link in the description box. I have made videos on how you can read and write data from JSON, XML, HTML, and also explained what these actually are. So as you can see, these kinds of data or these kinds of data are basically having some kind of two elements, I can say, a partial structure as well as it has a flexibility. They have some kind of a organization, but there is no fixed schema. Okay, they do have some kind of internal organization, but there is no fixed schema. So that like a spreadsheet. So these are all, that is why they are all examples of semi-structured. We know HTML, right? Suppose you know HTML, you see they will have tags, header sections, footer sections, various sections we do have. So some kind of a hierarchy is there, but not completely as structured like a structured data. Now what are the benefits of this is they are having a lot of advantages, like very flexible, they're quite adaptable. As compared to structured data, it's very nice. We can actually easily work on these kinds of data in machine learning. They're easy to analyze as well, and very good. You can extract insights from this semi-structured data as compared to unstructured data. So they're quite beneficial. But the challenges here is can be a little bit like tricky, can be a little bit complex to manage and process. You need to learn how to work on this data. That's the only challenge, and can be a little bit more difficult to secure than a structured data. So I will give links of all these files and how we can use these files in machine learning. So let's now quickly go through the differences between the structured, unstructured and semi-structured data. So structured data or unstructured or semi-structured, each one, as we just saw, they have their own flavor. They each one have their own unique strengths and each have their own challenges, right? To quickly summarize, structured data is more organized like files, right? In contrast, unstructured data is free flowing like a box of just information, but which is just cluttered. You don't have any kind of structuring there. And semi-structured is in between. It's a middle ground between the structured and the unstructured, and it offers good internal ordering but without any rigidity about the structure. So that's the main summary. So coming to the data type, in a structured data, the data is more organized with a predefined format, but in unstructured data you don't have any predefined structure. Semi-structured is in between. It has some kind of an internal organization, but it doesn't still have any kind of rigidity about the structure. No rules about this is how it has to be. Coming to the data storage, this is very good in relational database. You can use it. Unstructured data, we normally store it in file systems or data lakes, and semi-structured data we can use it in in file systems or NoSQL databases. Data analysis complexity is very low in structured data. It's very high in unstructured data because of the no structuring in the data here, and this is medium in semi-structured data. The scalability is limited in structured data. Unstructured data, you have very high scalability, and semi-structured you have in between. The use cases are, structured data, it requires quick retrieval. The tasks, you can use this in tasks that requires quick retrieval, precise calculations, or easy filtering. You can use unstructured data to capture rich details and hidden patterns. And semi-structured is in between. It bridges the gap between structured data and unstructured data. So that was about these three data formats. So please refer to the links on how to use JSON file, HTML files, XML files in Python programming. So let's meet in the next